I wanted a few minutes and graph a few more of the trig functions so that tomorrow we could really work on graphing the inverse trig functions. But today we talked about sine and cosine, so I want to talk to you about graphing tangent, secant, cosecant, and tangent. I won't go into quite as much detail as I did this morning since that was kind of an initial introduction, but I do want to talk to you about what the graphs look like and how to graph them. So let's start with tangent. And again, you'll want to reference your unit circle for this as we go through because it will greatly help you as we graph these points. All right, so we are going to use the same intervals here that we did for sine and cosine. We're going to go by half pi's on our graph. So pi over 2, pi, 3 pi over 2, and 2 pi, because just like we talked about this morning, we're going to need to take that out to 2 pi to see a complete revolution around that unit circle. Pi over 2, negative pi, negative 3 pi over 2. And I will probably do, well, I don't need to do autographs on the same one. All right. Ooh, it is not 3 pi, it is negative 2 pi. So if you haven't already, please be very, very accustomed to that unit circle. Keep using values, okay? So speaking of those values, if you look on your unit circle, you have places where tangent is undefined, and it is undefined at pi over 2, which means we're going to have an asymptote at pi over 2, and it is also undefined at 3 pi over 2, right? And so this is the pattern. And here we go. Tangent has values 0 at 0, pi, 2 pi loops around, right? Negative pi and negative 2 pi. And so when we do this graph, you'll see each cycle here looks almost like a cubic graph, right? And so on and so forth. All right. So here my domain is actually not what x can be, but what x cannot be, because x is not going to be, and I'm going to write this as a sequence of numbers here. It cannot be negative pi over 2. It cannot be pi over 2. It cannot be 3 pi over 2, and so on and so forth. Dot, dot, dot. The range, however, is not restricted. Your range is negative infinity to infinity. The period here is a little different, and you can look at this and tell. The period on this function here, from negative pi over 2 to positive pi over 2, so I have pi on that side, I have pi on that side, makes my period for tangent pi instead of 2 pi. Remember, for my sine and cosine, my period was 2 pi. Here is just pi. Okay? All right, and of course this is going. All right, so next we will talk for just a minute about secant. And to graph secant, you need to understand that secant is seen as 1, write this over here, secant x is 1 over kind of. Now, be very careful, because remember, when I am talking about dividing, I can never divide by 0. Dividing by 0 is going to put me an asymptote on my graph. So I'm going to still be here, let's see, I'm going to go by half pi's. Again, all of these, and whenever you zoom on your calculator, all of your dashes will go half pi's. I'm going to pause this a second and label and then. Alright, so again, I am using the unit circle to help me to know where to place my points, remembering that sin is 1 over cosine. So the first thing I'm going to do is look for anywhere on the unit circle where cosine, which is x coordinate there, where cosine is 0. And I see that cosine is 0 over 2. Remember, guys, these are parent graphs that we're going to manipulate. It does not look like secant, does it? All right, and it's also 3 pi over 2. And so you see the path happening 3 pi. So just like tangent, I have the same asymptotes here, okay? And so what I want to do is look at 0, right? At 0, the cosine is 1, so the reciprocal of 1 is 1. Now the difference here is the closer I get to pi over 2. For example, if you look at pi over 6, right? So at pi over 6, which is about right here, cosine value is square root of 3 over 2. So if I flip that over, I get 2 over the square root. So I get over the square root of 3, which is a little past 1, right? So what I'm getting, this is going to be symmetric here, because if I go negative pi over 6, remember that cosine value is the same. So what happens the closer I get, and go up to pi over 4, or actually let's go to pi over 3. At pi over 3, cosine is a half, so the reciprocal of that would be 2. So whenever I'm here, I'm all the way up at 2, right? So what's happening is it's coming up and hug this asymptote on either side, just this way. Okay? Now pi. What is happening at pi? At pi, cosine is -1, right? The reciprocal of -1 is, of course, -1. Now, as I move towards 3 pi over 2, okay? So if you're on your unit circle, put your finger on pi and move it towards 3 pi over 2. You move in that direction. Notice what is happening cosine. Now cosine is the x, okay? And you've got to think about cosine. Let's go to 4 pi over 3. At 4 pi over 3, cosine is never half. 4 pi over 3 is getting really, really close to here. We'll say 4 pi over 3. It's all the way down at -2. Okay, so it's doing exactly the same thing. From here, it is hugging the asymptote on either side. And this pattern is going to continue. And I know this looks crazy. Okay, and it would just continue here. For secant x, which is 1 over cosine x, my main, again, is everything it can't be. X not going to be negative pi over 2. So we need to do our little sequence of numbers here. Negative pi over 2. Pi over 2. Running out of room, I'm sorry. 3 pi over 2. Dot, dot. To let me know that that pattern continues on that way. My range is going to look a little bit different, because if you look at what data left out in the middle, right? So my range here is going to be negative infinity, -1. It includes -1 though, because there's a point there. And then from -1 to infinity. Okay. Let's look at one more, actually 2 more. I told a story. Let's look at cosecant. And I'm going to do this on the same graph, but I'm going to do it in another color. Cosecant, remember, is the reciprocal of sine this time, okay? So I'm looking at what is happening with sine. So I'm looking at places where sine is 0, but again, cosecant is the reciprocal of sine. I can't dispose of, okay? So in this case, it's happening at 0, so I'm offset, right? These are very similar, which is why I'm in these this way. At pi, sine 0. At 2 pi. So you know how sine and cosine are just look like about the same graph, but just slid over? Same thing here. And if I go through all the same steps that I went through when graphing cosecant, I find that in between the two, right, in between the two asymptotes, and I'm in purple right now, at pi over 2, the sine is 1, and the reciprocal of 1 is, of course, 1. And so I would have my little pieces here and here, and so on and so forth, and at P. And I know this looks a little messy. I'm just trying to save time. I don't want you watching videos all night. You have homework to do and get a quiz to get ready for, but also because I don't want to be doing videos all day either. Okay. Domain on this is a little bit different. This time the domain is what x can't be still, but it can't be from 0, and I'm just going to start 0. If you want to start negative, you can. 0, pi, I mean every pi, right? And then 2 pi, and so on and so forth. Okay. Here the period, each one of these is pi, just like tangent. Okay. And your range, for the range here, negative infinity to infinity. All right, quickly at tangent, I just wanted to do a quick little video on these that we didn't get to today class, because you may have some of those transformation questions on your quiz tomorrow. And the transformations work the exact same way, no matter what that trig function is. All right, so let's do tangent. So again, if you think about, here's what you have to think about. Cotangent is reciprocal of tangent, right? So tangent is sine over cosine. So if tangent is sine over cosine, that means cotangent, come on, been a long day, y'all. That means cotangent is cosine over sine. Okay? I keep wanting to say separate. All right, let's do our, this time I'm looking for places again where sine is 0. And places where sine is 0 are going to be on my undefined. There's over 2 pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. All right, so where is sine 0, or where is the y-coordinate 0 on your unit circle? And that is happening at 0. That is happening at pi. That is happening at 2 pi, and so on and so forth. So you can probably already tell my period is going to be pi, just like with cosecant, secant, and tangent. At pi over 2, I'm at 0. In fact, all of these I am at 0. But now let's really look to see which way this is going to go, because you know tangent, the closer I get to pi, the bigger my number gets, right? Bigger my tangent value gets. So you've got on your unit circle sheet, you've got the tangent values listed around the circle, right, on the side of boxes. So as you move from 0 to pi over 2, are the tangent values getting smaller or are they getting bigger? So look, you've got 0, square root of 3 over 3, 1, and then the square root of 3, right? So they're getting smaller as you move. Excuse me, they're getting bigger. But I'm not looking at tangent, I'm looking at the reciprocal of tangent. So I want to think opposite here, okay? So I want to flip these over, and I'm sorry, I'm not re-recording this video. From 0, as I move around, flip those over, okay, reciprocal. So 3 over square root of 3, 1 over 1, and 1 over square root of 3, okay? And so those numbers are actually decreasing when you look the flip. So they come this way, which means as I move more towards pi, those reciprocals are getting super negative super fast, okay? And this is the pattern that will follow for tangent. Domain x cannot be negative pi, 0, pi, and so on. Range all real numbers, and of course, the period here is pi. So I hope this helped you some. Get ready for your quiz tomorrow. It will be on transformation, period, or transformations of functions, periods, and amplitude, all that good stuff that I talked about, okay? See you guys tomorrow.